This is a presentation that we prepared for people buying telescopes, particularly at Christmas, because every year, come January, we get people turning up with telescopes which are either not right for their purposes or that they don't understand how to use. So this is just a simple guide to what you need to think about if you're going to buy a telescope either for yourself or for your child. The things to consider, very straightforward. How much do you want to spend? Only you can decide this, but obviously the more you spend, the more you get. Most people don't have unlimited pockets. The other thing is the age of the user and what is their experience, and does their age in any way inhibit the size and sort of telescope they can use. Size in terms of aperture is important, as we'll find out as we continue through this presentation. You really need to get as big an aperture as you can afford, given that it's of the required level of quality in terms of the optics. And the other thing is portability. Are you going to use it at home, or will you be looking to take it to somewhere with dark skies, in which case something really heavy might not be appropriate. So if you're going to buy a telescope, first thing you've got to think about is aperture, aperture, and aperture, because aperture will be the main factor in deciding how good an image you get, how bright an image you get, and how much clarity and resolution that image has. The other things you need to think about is what the mount type you want, the telescope type you want, and the accessories you want with that telescope. Now, at the moment, you may not know anything about any of these, so let's move on and see if this presentation can add a bit of clarity. First of all, the mount. Very simple things. It needs to be stable. Lack of stability in a telescope mount can contribute more to the dissatisfaction than almost anything. When you're magnifying an object, you need stability, because even the slightest touch at times can cause a distinct wobble in terms of the image, and even in some instances mean you lose the image altogether. Motorized mounts will track, i.e. they will follow the movement of the sky, which is caused by the rotation of the Earth. Computerized mounts will have what we call a go-to function, i.e. that once you correctly align them, they will be able to independently go to objects that you select within the handset. And you need to think about whether you want an all-TAS or an equatorial mount. Much of this will depend on whether you want to just do visual astronomy or whether you're likely to decide to try some astrophotography. So here's the alt-TAS. Very straightforward. All you've got to do is stick it on the ground, point it in the right direction. Ideally, you should make it level, but there's no real skill or refinement in using it, and most of them come with some level of fine adjustment. The cheaper ones can be rather unstable, and this particular mount is not very satisfactory in terms of if you want to look at the zenith. It's not very well thought through in that respect, and would not be the sort of mount that I would recommend. Here's the equatorial. Looks very sophisticated, but it has some conditions in its use, which is that it has to be balanced, i.e. the telescope has to be counterbalanced by the correct positioning of a counterweight. It also requires aligning to the pole star or to the celestial pole. If you're going visual, then basically this amounts to pointing it north, and what you basically need to know is where the pole star is. Once you've discovered how to find the pole star, visually it's fairly straightforward. If it's aligned correctly, it only requires to be moved in one axis to follow an object in the sky. And generally, because of this factor that you're only looking to rotate one axis, it's more easily motorized. Now, looking in more detail at the equatorial mount, in essence, the angle of the mount is set to your latitude, and this will determine the angle that the mount has to point to see the celestial pole. Now, if you're only going visual, if you set to the correct latitude and point the mount generally north, it'll probably be acceptable. If you want to go into astronomical photography, then you need to be a bit more sophisticated, and there are various ways of achieving this, but a lot of the more sophisticated mounts will have a polar scope, a separate telescope that's designed to allow you to align the mount. And it's not a question of pointing it at Polaris, the pole star, because in fact Polaris is not quite at the celestial pole, but it will allow you, with a graticule as illustrated, to set the mount correctly relative to Polaris. And there are a number of applications that you can get for a phone that will help you to do this. Go-to mounts, reputedly easy to set up, some easier than others, but basically you have to align them to stars. Depends on how accurate you want to be. Very often people will go to a single star or even part of the solar system, the moon or one of the planets. But for accurate alignment, typically it will be 2 stars or possibly 3. It takes a bit of mastering. It needs to know accurately your location. It needs to know accurately the time. So these are things to consider. Once set up, it will track the moon, the stars and the sun, all of which have different tracking requirements. The sun should never be viewed without the correct filtration. And of course, being motorized, they require a power source, which is often a battery, but can be a power supply from the mains converted to 12 volt, which is the normal power required by these mounts. Type of telescopes, 3 basic forms, although in reality it's a bit more complex, but for the purposes of today, it's a reflector, a refractor, or a compound telescope. We look at the reflector, invented by our good friend Isaac Newton, uses a spherical or parabolic mirror that focuses the light it receives onto a secondary mirror and then out through the eyepiece, which magnifies the image and allows you to view the image. Looking at the pluses and the minuses, they're generally very well priced in terms of the size or the aperture. Normally, for a given price, you will get a larger aperture and a reflector than you would with a refractor. And they even have a specific type of mount which is available only to reflectors, which is the Dobsonian, which is a very simple, generally manual mount that has the added benefit that it forces you to learn the sky, which is never a bad thing. Downside is they will need collimation from time to time, and the viewing position can be difficult, particularly on an equatorial mount. Worth bearing in mind for young people who perhaps are not that tall, because when you move a reflector to the zenith, the eyepiece is pretty high up, and you'll need steps or something for a child to get up and use that telescope. The refractor, oldest type of telescope known to us, it uses a lens that brings the light to focus out through the eyepiece, in this case using a diagonal mirror for convenience. You look at the pluses and minuses, it's easier to use than a reflector. It requires very little maintenance. It has no central obstruction like the secondary mirror, so therefore for a given aperture, it will capture more light. Having said that, inch for inch are more expensive than reflectors, and on the lower cost models there will be distinctive colour fringing, or what we call achromatic abrasion. If you want to get rid of that, you have to go and buy something called an apochromatic telescope, which can be very expensive because it involves the use of several lenses of various types of glass that counteract this fringing effect. Compound telescopes, as you can see, they have a primary mirror, but before the mirror receives the light, that light passes through a correcting lens, commonly known as the correcting plate. The light then bounces back up to a secondary mirror, which in the case of a Maksutov is actually built into the correcting lens, whereas with a Schmidt-Cassegrain it's a separate entity, which in more sophisticated telescopes can be removed to allow a camera to be fitted to achieve a very fast short focal length, which is very good for fast exposures of deep sky objects. But basically they're very compact. For a long focal length you get a very short tube because of the light passing backwards and forwards within the tube. They're very low maintenance, very little need for collimation. Very occasionally they will need to be collimated, but not very often. Certainly not as often as a reflector. They are absolutely ideal because of their focal lengths for the moon and the planets. Less good for the very faint deep sky objects. They can be very heavy because of their construction, and this implies that you need a very substantial mount in which to mount them and use them. And because of all these factors, they are relatively expensive. We look at accessories. Common accessories: a finder scope or a red dot finder, eyepieces, absolutely essential, and normally those supplied with a telescope aren't of the highest order. And you may actually look for a camera attachment either to connect the DSLR or, in fact these days increasingly, a smartphone. The finder scope sits on the side of the main scope on an adjustable bracket. If you look through it, it has a reticule, and basically you align that scope by adjusting the bracket so that the image in the scope, the finder scope, is the same or is centered on the image that's in the main scope. The advantage that a finder scope has is that it is a telescope, and therefore, although it's a lower magnification than the main scope and a wider field of view, it will have light in excess of what you would see with the naked eye. So sometimes with fainter objects, you can actually see them for alignment in the finder scope. Depends on the size of the finder scope. These vary from 30mm aperture to 60 or even 80mm aperture. Depends on what you pay. But the main thing with a finder scope is it must be carefully aligned. Good thing is that with a scope you can do this in the daylight on a church steeple or a pylon. There's never a problem. A red dot finder, on the other hand, really needs to be aligned at night because you generally can't see the red dot in the daylight. And it doesn't magnify the image, it doesn't increase the light gathering, it's simply a question of using the naked eye. And you generate, or the battery system generates a small red dot that is positioned onto a distant object, top of a pylon, top of a tree, top of a church steeple, whatever, and that is then also aligned to what is viewed in the main scope. Sometimes, and in my case it's true, that I use one of these in conjunction with a finder, because I use a right-angled finder that is very convenient to look through, but rather more difficult to align initially. So the red dot does the initial alignment, and then the final positioning is through the finder. Eyepieces. They come in two standard sizes, 1.25" and 2". Never be tempted to go for a telescope that has eyepieces smaller than 1.25". Partly because generally the optical quality is not as good, but also because it limits your choice in terms of buying eyepieces. And eyepieces are one of those things that you'll almost certainly go out and buy after you've bought the telescope, because you'll want to improve on the eyepieces that are delivered with the telescope. The focal length of the eyepiece is what determines the magnification, and counterintuitively, the higher that number, the lower is the magnification. And you achieve or understand the magnification simply by dividing that focal length, in this case 15mm, into the focal length of the telescope. And the result of that calculation tells you what the magnification is. It's also essential that you choose eyepieces that give good eye relief and a good aperture to the eye aperture. This makes them easier to use, more comfortable to use. And you shouldn't underestimate this, because some people find eyepieces quite difficult. And one of the common problems is people squinting when they use an eyepiece. You really need to train yourself that you can keep both eyes open and basically get your brain to ignore the eye that you're not using at the telescope. So these are what you have to decide. These are the things to bear in mind. What's the mount type? What's the telescope type? What accessories am I getting with that telescope? And above all, please remember, aperture is king. Always consider the aperture and always really try to buy the biggest aperture you can afford. A couple of little suggestions here. If you're spending less than £100, then buy binoculars. 100 to 200, you can look for a small refractor or reflector, but I would probably never recommend a reflector less than 5 inches or a refractor less than 70mm, because otherwise you're going to be very disappointed with what you see. 200 to 300, good buy is a manual Dobsonian reflector, 6 or even 8 inches if you can get one. Very versatile instrument, good imagery, and a lot of telescope for your money. Over that sort of figure, you can start looking at go-to telescopes, be it a reflector or even one of the smaller 127 Maksutovs, which are extremely good telescopes, particularly if you're interested in the moon and planets. Hope you enjoyed this. Hope it's been useful for you, and hope you got some benefit from it.